going to wait to start using my PowerPoint presentation stuff. I'm Julian Torres. I am a postdoc in University of Constance in the lab of Axel Mayer, and apparently my presentation is too heavy. And today what I want to tell you a little bit about is how a project we are doing in the evolution of genital asymmetry in a group of library fish from South America and its consequences for their mating system, particularly for multiple paternity. Oh no. So, well, I will keep going. So today I will talk about the family of South American fish. These are Anablepides. This is the sister family of Quasilides, which are very well known. It's composed of three genera. One is just composed by only one species, the white-eyed fish, and the other one has three species of Anableps. This is a more known species, the four-eyed fish. And then the family, the genus I will be talking today, it's Genincia. It's a group of 14 species, more or less, of South American library fish. And there we go. So, yeah, my general question is why actually females do mate multiply, and there are different explanations. It could be direct or indirect benefits or consequences of coercive mating, and of course these are not mutually exclusive. Then we can ask if multiple paternity is a necessary consequence of coercive mating. And to address this question, I'm working with this family, and these are the fish I will be looking at, Genincia, with 14 species. And we can dissect the name here. One side, the libraries. It's tricky. Libraries is because they give birth to, there is viviparity, which evolve only once within the family. So the white-eyed fish doesn't, they lay eggs, and the two genera, Anablepis and Genincia, give birth to quite developed offspring. The other part of the name, the one-sided, is because there is internal fertilization, and to do so they evolve a gonopodium, which is a tubular structure modification of the anal fin. Here you have a female, here you have a male, it's a little smaller, and female has a normal anal fin, but the male has modified the rays into a tubular structure that is elongated. And then one-sided thing comes from the asymmetry in that structure of the gonopodium. So here you can see from a male from the belly, this is the gonopodium here, and you can notice the tip is bent to one side, and this is because the males have a hook, a sided hook, that aids in inseminated females. And what I think is very interesting about this fish is that within populations you find both morphs. So this is a left-hand male, a right-hand males, and then the females are symmetrical. And there are a lot of traits that correlate with this, and that might have implications for mating behavior. The obvious one is laterality in mating behavior, and there is a perfect association. This is a laterality index, so this is an excess of event on the left side, this is an excess of events in the right side, and you can see a perfect association with morphology of the gonopodium. What's obvious is that there is changes in the lateral line where left-handed males have an excess of neuromass in the left side of the body, and right-handed males an excess in the right side of the body. And this might have implications. You can see how close the males have come to the female to be able to inseminate them. The gonopodium is quite short, and their heads is up here, so they cannot really see what they are doing, and the lateral line may help them position themselves during copulation. Something very interesting is when you look across populations, what is going on is that we see fluctuation around 1-to-1 ratio between the left and the right males, particularly in these species that I looked at. And this is not only across populations, but within populations we see certain level of oscillation in the ratio of those two that suggests some interesting selection going on in the relative abundance of those features, of those two morphs. And we know from previous studies that in general, asymmetry in genitalia is associated with coercive mating system. And that has been seen in Cosidius, but also in other vertebrates like ducks. So, and this is in line with the mating system of Genesius. So here you see a female swimming away and two males trying to copulate with her. Females constantly try to avoid males. Males chase them constantly. They attempt many copulations. And females sometimes try to attack them, but most of the time trying to swim away of them. And you can see here that she cannot guard any of the side preventing copulations, because when she guards one side, males come from the other side and vice versa. And at the same time, males cannot monopolize the female because they are one-sided, so they can protect one side but not the other one. So once they try to protect one side, the other side is and this is the norm across the genus, but it's not the only pattern. So very interesting to me, we found 3 species that actually depart from this 1-to-1 ratio, where we see most of the males being left-handed, particularly in these 2 species, where in one all the males are left-handed, and in this one more than 95% of the males are left-handed. So this gives us the opportunity to ask what are the consequences of this variation in asymmetry for multiple paternity and how interact with coercive mating. And to do this, we ask 3 questions. The first one is if indeed this phenotype, this asymmetry in the genitalia, and this coercive mating result in very high level of multiple paternity, especially compared with other library fish. And the other ones is if we see an increase in the number of sires that linearly with the number of offspring, which will suggest that it's a random usage of the sperm pool that the female got from the multiple populations with multiple males, or actually there's some evidence for post-copulatory selection where we see some kind of paternity skew when one of the male sires disproportionate amount of offspring within a group. To see for this, I genotyped 700 offsprings conducting paternity analysis. This came from a brood of 68 wild-caught females from 10 different species, and I used 3 polymorphic microsatellites. So the first question is, indeed we find that they have very high level of multiple paternity. So in this graph, what you're seeing is the frequency of broods being sired by more than one male. So within one species, so here will be a species where all the broods are sired by only one male, and this will be a species where all the broods are sired by more than one male. When we plot Genesius into this, we see that it's completely biased toward multiple, high degrees of multiple paternity. Another way to see this is that we can ask how many of the brood, the average number of sires per brood or per species. And this is library fish data from 30 different species of library fish, and when we put Genesia here, we see that they are skewed towards very high levels of multiple paternity and having multiple sires. So they do indeed, this coercive mating results in very high level of multiple paternity. So moving to the other question is, does genital asymmetry affect the of multiple mating? What I will do is first tell you the results from this group of species here, or populations, and then I will expand that to the other species. So the first result is we see that the number of sires do increase linearly with the number of offspring in each group, and significantly. And also what we see is no evidence of skewed paternity. So in this plot, what you see is 40 different broods, and here in different colors you see different males, and this is the proportion of offspring side by each of these males. And out of the 40, only 3 show skewed paternity. So paternity skew is very, very low in this fish, which would suggest that there is no much post-copulatory selection. And this is consistent across all the different species that have a 1-to-1 ratio, like you can see here in gray in all these species. It's quite consistent. Many, many males per brood and no much skewedness. But when we look at those species that depart from this pattern and have an excess of left-handed male, we see a different pattern of paternity. In one of them, we see that all the broods are sired just by 2 males. In the other one, we see more males, 2 or even 4, but it's always very skewed, significantly skewed, where 1 male sires most of it. So when we go back to this mating system, what look like is that the change in asymmetry, or the frequency of the direction of asymmetry, has affected the sexual selection scenario. You can imagine now you have a female that will be receiving or trying to receive the population just from one side, so she can actually respond to that much better. And at the same time, a male can monopolize that female for a while, just staying on one side. So we can imagine here that the scenario changed. So what I would like you to take from this message, from this talk, is that genetics is a very interesting system with high level of multiple paternity, and it's a group of species where you can infer that multiple paternity is indeed the consequence of the coercive mating system. But there are a few exceptions within this genus that make it very interesting and allow to test for different sexual selection scenarios. And with this, I want to finish my talk, and I want to thank all my collaborators, and especially my founding sources, PFG and University of Hong Kong. And I have time for questions. Yes?
In the species with the strong dissimilarity in terms of the number of like 90% are one way and 10% are the other. Is there a rare male advantage?
Yeah, given the results we see, it's possible, but we actually took wild-caught females, and we didn't collect males to know if the difference are. I wouldn't think it is, because then we will see a cross-population variation in this frequency, and we don't see it always across all populations. Most of the males are left-handed. Yeah?
What program did you use for paternity?
I use Colony. Thanks. All right. Thank you very much. Oh, sorry.
Just like, how is there not any advantage for awareness? I know results are moving, I guess. If, say if like 10% on one side and it's protecting that side, but why do you think there isn't an advantage for
It's a very good question. Like I said, I don't really know because I only collect the wild-caught females. These fish are quite difficult to maintain in captivity, but it's a very good question why it's not a rare advantage there.